Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. This exact session is of the part 2 on data frames. In the previous section, we saw what data frame are and how they are made. We also started using the data frame constructor to create them. And in this section, we will see together the different way of building a data frame depending on the types of input data used to enhance them. But before we begin, we want to let you know that we have divided this session into 3 parts, each covering a specific aspect of topics. So by subscribing to our channel, you will never miss any updates and get notified of our latest videos and series. Let me just dive into the topic creating a data frame, and we are just going to see various ways to build the data frame. And here it is, the first one. Let me just get it from NumPy array. And we have already seen in the previous section using the value attribute that the values within a data frame are nothing more than a two-dimensional NumPy array. So it is therefore clear that the simplest and most initiative way to enhance them is to use previously created array as let me just see it in the example. So kindly just have a note of it. This is the index. I'm just going to make it as like a variable, and to this variable I'm just going to give the elements. Let me just make it A, B and C. So of course this is what the index. So of course by this we are able to know that we are going to have 3 rows, and this is what the column. I'm just going to create it by using the same NumPy array, and here I'm just going to give it in uppercase. That's too easily differentiable. Okay, so this is the column, and let me just create the array, that is the element. So here we go. So let me just make it towards the nested functionality. So as we have seen in the previous, okay, so this is what the element. Okay, so let me just create the data frame, and of course we already have seen this is the exact syntax that we are just going to create it. And first one, it is all about the data, and second, it is all about the index. Of course we have created the data from the NumPy array, and the index that is also in an array, and the variable name is idx. And the next one, it is all about columns, and we have already specified the columns as like COL. Now let me just print the data frame. So here we go. So but the most interesting thing is to use the NumPy functions that generate values automatically in a similar way to those we used to populate the series. And only in this case we need a two-dimensional arrays. In the series we used np.arange function to generate an array with a separate of integer. If we concatenate that np.reshape of x comma y method, it is possible to generate a two-dimensional array having x rows and y columns from this sequence. Okay, let me just make it towards that. So kindly just have a note of it. This is what my second data frame. I'm just going to create it. So this is my data frame, and kindly just have a note of it. With a range, I'm just going to give the values 1, and this is what my data. And here I'm just going to give the reshape of row comma column. So here I'm just going to give that row comma column. It is of 3 into 3 matrix, and this is all about that index, and last it all about the columns, of course, COL. So now let me just print that data frame. So see here how it is. So the same is true for the np.0 methods too. So here too we can just make use of that reshape, and in concatenator to convert the sequence of 0 generated into a two-dimensional array suitable to be accepted as the input. So given by the data frame constructor. So if I just want to make the same thing, kindly just have a note of it. What I'm just going to give is, instead of this a range, let I just give zeros. So I'm just going to give zeros. So in that zeros, how many? Of course, it is all about 9. So let I just make this as a data frame of 3. So let I just convert this to. And kindly just have a note of it, dear friends, how this happens. So just view the output. It is all about the zeros. And it is possible to generate an array of random numbers using that rp.rand.rnd functions, and then by concatenating this functions to reshape. That is also can be done here. So let I just try that. A random number. So instead of here, this one I have already copied from the previous. So I'm just going to change only the variables, and here instead of a range, I'm just going to give the random. So kindly just have a note of it. So random dot rand n, and here let I just give 9. So this is how. So concatenated it with the reshape. Now let me just have a look of it. So here the automatic value generated function has been used, and it is possible to initially populate large data frame, impossible to do manually. It is writing the arrays by hand. And kindly just to see, at least it is just making it try of a random functionality. Okay, now let we just create a data frame from a series dictionaries. And dictionaries. Okay, kindly just have a note of it, dear friends. At the beginning of this today's session, to facilitate the understanding of the internal structure of a data frame, we had given the example that data frame could be thought of as an union of some series. So having the same index and the same length. Yeah, well, this example is just what we described. I'm just going to give here, and a data frame can be built through the use of dictionary in which the key value pair are represented by the column labels as key and the series as values. So let me just see it. So have a note of it. So this is what series 1 and pd.series, and here I'm just going to give the values. So kindly just have a note of it how I'm just going to give, and here it is that index. So this is what the index, and I'm just going to have this copy of index for the next series also. So this is series 2, and here I'm just giving the series 2, and here it's all about 2, 5, 8, and here it is the same index, and of course the last series which I'm just going to concatenate, and here it's the element which I'm just going to give is 3, 6, 9, and I just copy this. Now kindly just have a note of it. I'm just going to make this exact series as the value, and I'm just going to give it to a dictionary. So this is what the dictionary, where I'm just going to give the key value pair, and kindly observe here what I'm just going to give is series 1, and next it's all about the series 2, and lastly, so here I think you are all able to just observe that this dictionary here, it just comes from the series. And let me create the data frame here. So pd dot data frame, and I'm just going to create it from the dictionary, and let me just print the data frame 6 and observe. So now let's move on to a more complex but general example. So let's say that the series we want to use are not all of the same length, and they are also contain or not whatever be, so other key values that we do not consider. So let me just have that example here. So how I'm just going to give is, so this is what, let me have this as my example. I copy this, and here the first of all, for this first series, let I just include some more values. So this is what, and here of course to the equivalent thing, I'm just going to give the rows also, that is the index, and kindly just have a note of it. This is 258, let it be the second series, and let me just have one more element in the series 3. So here also I just want to include one more, let I just make it as a D. Okay, now yeah, here it is the dictionary, A, B and C is there, and of course let me just differentiate this with a data frame 7. So now let me have this output. So see here dear friends, as we can see from the result, the data frame constructor is able to work very well with dictionary. It is perfectly able to take into consideration all the index label of the series, even if not in all, and based on this align all the corresponding values in a table. If the labels are not present in the corresponding column, it will insert a NaN, that is the not a number, which we just specify as like a missing value. So thus managing a lack of information. So furthermore, the constructor can do this work even if the index labels present in one series follow a completely different order in the others. So from this behavior here, we understand the potential of a constructor such as data frame constructor. So if on the other hand, we do not want to take into consideration that other labels, but what to keep only the values of those those labels established by us. So we can carry out filtering as a manufacturing level without subsequently what we just said, that is cleaning the unwanted information. Yeah, this can be done by specifying only the labels we want in considering as an indexed argument. So for your information, let I just make that here. So to make it as a differentiation, let I create that pd.dataframe alone. Kindly just observe here dear friend. So this is my data frame. So I'm just going to get it from the dictionary, where here I'm just going to specify only the index which are available along this. So here we go. So now let me print this data frame. So see here dear friends. So however, there remains a missing value to maintain, to manage some any values if it is not. So as you can see, the working with more general cases, we approach the case of real data in which problems of missing or incorrect data can often arise. Okay, fine. Let me just take one more example, that is creating a data frame from an n-array dictionary. Okay, so let me just make it an n-array and a dictionary. Okay, so see here, a very similar case to the previous one, to use that is an n-dimensional array dictionary or generic list. Okay, so same rules and same behavior, except that in this case we added an n-dimensional array. We are just going to make it to populate the index. So since n-dimensional array do not contain this type of information, okay, so anyhow, let me just make use of something related to n-dimensional. I just copy this from here. Okay, so let I just make this as my element, or if I have specified anywhere. Okay, no. Okay, let me just make use of the thing. So here we go. So first of all, NDA, this is what first dimensional. I'm just going to make it so let I just give 1, 4, 7 as one among the values, and here let it be the second, and here I'm just going to give 2, 5, 8, and the last one, it is n-dimensional 3. Let me just give the different values. That's 3, 6, 9. Okay, now what is the next? IDX, that is the index. Okay, let I just create that's true with an array, and here we are making it very simple with the same examples, and kindly just observe. So here it is the dictionary, and what is it? So the dictionary, which it just has the key and value pair. I'm just going to give n-dimensional array. So here it is n-dimensional array 1. So what's next? Yeah, of course, the second key and second dimensional array, and to the last, here I'm just specifying n-dimensional array 3. So now let me just create our new data frame, and this is pd.dataframe. Here, what is the first one? It is all about the data, which I have just given it in the dictionary, dic, the variable, and next all about the index. Okay, so let me execute it and see what is there in the data frame. So see here, dear friend. Yeah. And next one. So previously we have seen one of the session as like pass by the reference, and here let me just go with pass by copy with dictionary. Okay, so dear friends, the data frame constructor has a completely different behavior with dictionary than the NumPy array. In fact, if a value of type dictionary is passed as data input, it will make a copy of all the values contained within it without any passing by reference. So this is so regardless of whether there are series or n-dimensional within the dictionary. So in fact, in the case of a series dictionary, okay, so if we modify an internal value of a series, the dictionary will be changed in turn, which is not the case of a data frame. So kindly just have a note of it, how we are just going to make it. So this is what series 1, and let I just check what is there in A, which I have just already given 8. So here I'm just going to make it, I don't know whether I have just already given this series 1. Okay, and let me just try this. What I'm just going to have it in the difference of I think it is 6, where I just given in the series. Of course it is 7. Yeah, 6 and 7 both are there in the series. So let me just have it in the 6 itself. So let me see here. So this is what the exact value, and yeah, we are given this one. So how come the value of A? Of course it is not changed now. So let I just give some different values here, and let me just check it. So we find the same consistent behavior in the case of dictionary of n dimensional, and here too, by changing the value of n dimensional, okay, the dictionary will be changed while the data frame generated by it will not. So see here, where previously we are just having this is as our own NDA. Okay, so let me just make that as NDA 1. I'm just going to give 0 here. Let me just convert it into 0. Now let me print the dictionary, and let me just go towards the printing of df9. So see here what happens. Of course there is no changes happened. So in this we are just going to create a data frame from a list of dictionary. And dear friends, we have seen that the combination of data types, nesting them one inside the other, and yeah, we can just generate a large variety of structured data in Python, as like previously we have just seen it from the list and from the series and NumPy array. And now let me just create a data frame from the list of dictionary. So see here, dear friends, so this one, another very common combination in which data can be found is that of the list of dictionary. Okay, so let I just give, this is the exact variable. Let me just create a list here, and of course inside the list I'm just going to give the dictionary. So let me have, this is the key and the value, and let me just go for the next key and the value, and to the key, sorry, let me just give it in uppercase, and the value. Okay, so this is one among the key. And kindly just note, I'm just going to copy this, and because it is all about the series, so kindly just have only the values I'm just going to change here. 4, and it's 5, and it's 6, it's 9, 8, lastly 7. So see here, dear friends, this is what my list of dictionary. So this is the exact variable. Let me just have a look of it, how it seems to be. So I'm just going to give a print and execute it. So also in this case, yeah, we can think of a conversion into a data frame through its constructors. Okay, so providing that the elements inside it are properly structured to meet our needs. Okay, so let me just create the data frame, and yeah, pd dot data frame, and let me just give the exact, the data is list dictionary, and of course here we have to give the index, the next attribute, and this index let me just give in lowercase. So this is what the row, that is the index, and let me see, execute it by printing it. So see here, dear friends. So, of course, in this session, we also presented how the data frame constructor are able to construct these objects receiving common types of data such as lists or tuples and dictionaries as input and in different combinations of them. And yeah, next let me just see how to make it with an multi-index data frame also. And dear friend, yeah, if you want to take your learning to the next level and kindly join us on the exciting journey, don't forget to hit the subscribe button and turn on the notification. Let's see you on the next part 3 session. Thank you, dear friends, and happy learning.